So next on my DNA matches in the ancient bloodlines, Mesolithic 2 era, ceramics maker in China. Boshan 11 is the identifying number. Shandong, China. I match 0.34% with this sample, genetically closer than 23.4 of another genome link users. And again, I only know my mtDNA, and the tests they do on genome link is autosomal. So literally, it could come from my father's side or my mother's within me. But I always do check, is there a connection, way back in the mtDNA line. So let's have a look and see what we can find about this sample. So, this sample is from a Northeast Asian man of an early Neolithic period. His remains were discovered in Boshan Mountain in Shandong, China, and dated to be from 8,320 to 8,040 years old. DNA was extracted from his tibial leg bone. His mitochondrial haplogroup was identified as B4C1A, and his Y chromosome N-F2905. The colonization and genetic history of Asia, especially East Asia, is more complicated than that of Europe. The geographic region of East Asia comprises China, Mongolia, and Korea. Geographically, the Boshan 11 sample is from the coastal area of northern East Asia. At the lowest stage of the Yellow River, it contrasts to the inland northern East Asia, which is the inner Mongolia. During the Neolithic period and earlier, East Asian populations were genetically more diverse, and traces of this diversity can be found in today's population. Neolithic East Asians are more similar to Neolithic Siberians and Tibetans than to early Asians. Early Asians had common ancestry with Austronesian populations and Andaman Islanders. Boshan 11 is frequently used in scientific literature as a reference proxy for Shandong hunter-gatherer, in brackets Shandong EN ancestry. The north-south split, his genome helps define the ancient northern East Asian ancestry cline, which contrasts with the southern East Asian ancestry found in Neolithic Southeast China and Taiwan. The Neolithic turnover genetic models show that during the Middle to late Neolithic, massive waves of millet farming populations from the Middle Yellow River Basin migrated eastward into Shandong. This caused a population turnover, diluting the original Boshan 11-like hunter-gatherer ancestry. Despite the turnover, his genetic profile did not disappear. Middle Neolithic cultures like the Dowenko culture, inherited roughly 40% of their ancestry from early Shandong hunter-gatherers like Boshan 11. Through them, this ancestry was carried further north, contributing to the genetic formation of the famous Hongshan culture in northeast China. So, because Boshan 11 was discovered during archaeological rescue excavations and primarily featured in massive broad-scale paleogenomic studies, such as the landmark papers by the Chinese Academy of Sciences, highly specific bioarchaeological details about this individual cause of death and exact grave goods are sparse in English scientific literature. However, looking at the context of his discovery and the holy culture to which he belonged, we can reconstruct the details of his death, burial, and the accompanying goods. Cause of death, no signs of trauma. There is no recorded indication in the osteological reports that Boshan 11 died a violent death, such as battle or trauma. Likely a natural or disease-related death. Like most individuals from the early Neolithic, his death was likely due to the typical hazards of prehistoric life, such as infection, seasonal food shortages, or illness. Bone preservation. His skeleton was well preserved enough that scientists successfully targeted his thick tibia shin bone to exact extract clean, undegraded ancient DNA. He was found buried in the mountainous terrain of Boshan, Zibo, Shandong province. Hauli culture burials are typically earthen shaft graves or single pit graves dug directly into the ground. Individuals from this region and era were usually laid out in an extended supine position, lying flat on their backs, legs straight, rather than flexed or crouched. Egalitarian layout. Early Neolithic burials in Shandong show very little social stratification. He was buried in a modest community setting rather than an elite or segregated tomb. Because he lived at the very dawn of Neolithic transition, when human groups in Shandong were still primarily mobile hunter-gatherers, shifting toward early semi-sedentary lives. Graves from this era are notably sparse. While scientists did not conduct a specific individualized dental calculus or stomach content analysis on Boshan Levin, we have an excellent understanding of his lifestyle based on regional stable isotope analysis and the extensive excavations of his group, the Howley culture or the Holy culture. Because he lived precisely during the transition from foraging to early farming, his diet and clothing were completely tied to the local forests, rivers, and wildlife of Neolithic Shandong. Boshan 11 had a rich, diverse, and broad spectrum diet. He would not have been a strict farmer, but rather a hunter gatherer, fisher, who was just beginning to experiment with early plant management. Animal bones found across Holy culture sites show that he ate significant amounts of silka deer, roe deer, and wild boar. Living near the streams and coastal basins of Shandong, his people were avid fishers. They consumed large quantities of freshwater fish, clams, and river turtles, catching them using specialized bone harpoons and early fiber nets. Isotope data from this era shows that human bodies were starting to process C4 plants. Archaeologists have found the earliest traces of foxtail millet, broomcorn millet, and even early rice at holy sites. These grains were not staple crops yet. They were gathered wild or tended in small experimental plots to supplement the diet. He ate seasonal wild plants, including walnuts, hazelnuts, acorns, and wild fruits from the foothills of Boshan Mountain. The Huli people had just begun domesticating dogs and pigs. While pigs eventually became the primary food source in later Chinese dynasties, for Boshan 11, they were a rare minor supplement compared to wild deer. So no actual fabric or organic clothing survived from Boshan 11's burial due to the thousands of years of soil decay. However, the preservation of the tools used to create clothing tells us exactly how he dressed. Given the temperature seasonal climate of northern China, his primary clothing consisted of leather and fur pelts from the deer and boars he hunted. The Huli culture did not just drape raw skins over their shoulders. Archaeologists frequently excavate bone awls and polished bone needles from these sites. This proves that Boshan 11 wore fitted, stitched clothing using animal sinew or plant fibers as thread to sew hides together for protection against chilly northern winters. While silk and hemp farming came much later, early coastal East Asians used wild hemp, grasses, and tree bark. They stripped, pounded, and twisted these materials into coarse, woven mats, rudimentary aprons, or footwear like sandals. Rather than metal or jade jewelry, any personal adornments, Boshan 11 or any of the other culture would have been crafted from nature. Holy sites feature small decorative items made from carved animal bone, deer antlers, and pierced river shells. So, how do I connect with this sample? So, B4C1A and J1C3 connect to an original maternal line. But you have to travel incredibly far back up the human family tree to find this shared ancestor. Because mitochondrial DNA is passed down strictly from mother to child, every maternal lineage on Earth ultimately traces back to a single woman, known as their mitochondrial Eve, who lived in Africa roughly 150,000 to 200,000 years ago. However, the specific junction where the branches of B4C1A and J1C3 split is at macrohaplogroup R, an ancient maternal clan that originated roughly 60 to 65,000 years ago in Southwest Asia or the Near East. To visualize how Boshan 11's maternal line and the European Near Eastern maternal line J1C3 connect, you can follow their lineages back up the tree. They're two divergent paths. After mutating away from their shared R ancestor, the two lines went in completely different geographical directions. The path to B4C1A, the eastern branch, the descendants of the B branch migrated eastward across Central Asia and settled heavily in East Asia. Over tens of thousands of years, this line developed the special mutation for B4, then B4C, and finally B4C1A, roughly 18,000 years ago. This is the exact indigenous coastal lineage found in the 8,000-year-old skeleton of Boshan 11, Shandong, China. The path to J1C3, the western branch, the descendants of the J branch stayed in the Near East and later expanded into Europe. The specific sub-branch J1C emerged around the peak of the last glacial maximum around 16,500 years ago, while the J1C3 expanded rapidly into Europe alongside early Neolithic farmers and hunter-gatherers. Today, J1C3 is commonly found in people of European descent, particularly in Northern and Western Europe. You and Boshan 11 share a direct great-grandmother to great-grandmother line stretching all the way back across the generation. Continuing the journey, Mesolithic 2, Baikal Lake, hunter-gatherer, DA245, Irkutsk Oblast, Russia. A match 0.22%.